Well, maybe I'll just get started. I thought I'd start by celebrating today, and we have all of our friends and other people of similar interests, and I thought that was very special. You know, it's kind of a quirky hobby or, you know, niche, so to speak, and you know, I'm very grateful that we're able to get together in person and also virtually, whoever's watching, and and then also thanks to the organizers and volunteers who have spent countless hours doing all the good things that they do to make this event possible. So thank you, everybody. All right, this one's about FUZIX, and I guess a little bit about me. I'm a lifelong learner, interested in programming languages, operating systems, and a little bit of hardware. Specifically, I like the Zilog Z80 stuff, Z180, and in particular, Motorola 88,000 class stuff, and everything else that's old. So VAXs, PDP-8s, everything here is pretty much interesting to me. So that's something. And when I'm not doing computer stuff, I do tree climbing and rock climbing. And I'm also an amateur radio operator. Recently, I've been doing HF, FT8, and JS8 call stuff, which I find it fascinating. So, what is FUZIX? So, first of all, let me just say I speak with no authority in this matter. I'm more like a tourist. You know, I had a little project earlier this year, and I've known about FUZIX for a while, but you know, had a chance to dive in a little further, and I'm basically going to speak sort of like a travel log. So I went there, did that, and this is what I saw, and this is how it was, and you know, it was a lot of fun. So check it out yourself if you're interested. So FUZIX is a Unix-like operating system for small systems, and by small we mean pretty much an 8-bit processor with, however, not a small amount of RAM, but a large amount of RAM for 8-bit, which is to say, like on a Z80, the minimum's thought to be around 128K, which means, you know, there's going to be banked memory stuff. On a 6809, it's said to be perhaps possible to get everything running in 64K. I've never tried it myself. It's built like the older systems, the older Unixes, basically version 7, system 3, and some system 5 bits. It honors POSIX, so it's not really what's called heritage Unix. It's more of a modern interpretation of a Unix-like operating system that runs on a Z80. So it is currently in active development. It's written by, or it was started by a guy, hold on, I can get to the history. It was started by Alan Cox, who is a retired Linux kernel maintainer. So he was, you know, he knows his Linux, he is Unix, he's a very prolific programmer, and he started this back in 2014, 7 years ago. First commit, and since then it's been in active development by a number of people. And there was a milestone release of 0.3 in the August 2019 timeframe, and we are currently in what's called pre-0.4, which is to say that, you know, I guess when Alan's ready to formalize the interfaces, this is what really the version number is about. To publish sort of an interface that says we're not going to break this for this version. When he's ready to do that, I guess we'll get 0.4. Stepping back a little bit, here's sort of a list of some of the systems that were mentioned. The list is actually much longer than this, but I picked out a few that, you know, that might mean something to. Well, they meant something to me, so I listed it. So there's the Amstrad, there's the Dragon 3264 Tandy Coco 2, which is to say the 6809 machines. There's Memotech, which I've never seen myself, Micro:bee. I happen to have a P112, which is, I think it's called Digital Design P112, It is a Z180 with a meg of RAM and a couple 4 serial ports. It also has the GIDE, which was sort of an IDE interface back in that time. This was 2006, I think. So in my case, I have a compact flash attached to that. It also goes Sinclair ZX Spectrum, Tandy Coco 3. I know the Tandy Coco and the 6809 development seems to be pretty solid. And then TRS Model 4, 4D, 4P with 128K RAM, which I think my interpretation of this is that that's sort of a stock configuration without any additional hardware or whatever. Then there's Steve Cousins, series of single board computers, SC108, 114, and other various, Z180 or Z80 machines, boards, and RC 2014. In that configuration, there's a bunch of, yes?
Would there be anything for bank switching CPM type systems, generic S100?
If you can do bank switching, there is a chance that it can be made to run. Yeah. So on the Z80 front of things, if you can bank switch, give or take, with a total of about 96 to 128K minimum of RAM, you can probably make it work, or it seems like that's possible. RC 2014, there's various different combinations, and there's a guy on YouTube that demonstrated FUZIX, so I think that's also covered. And then there is the 68K, so I think active development currently on Ataris, as well as the tiny 68K board, I think. And then recently, just earlier this year, there was one for the Raspberry Pi Pico, and also for the ESP8266 kind of stuff. So we did the history, and we could talk a little bit about the features. And yeah, so if you're interested, I'll put up a link to the GitHub, but you can take a look at the the systems that are listed, comments about that. There's been an ongoing, can this be done on Apple II discussion, and as of recently, there was some kind of new discovery that maybe with some additional hardware, people are going to make it work. We'll see. Some of it has to do with also, I'll mention later, but the compiler. So let's just touching on the features. My personal favorite #1 feature is that it's small enough to understand. So I've built Linux systems, NetBSD, OpenBSD, FreeBSD, all those. I've gone through the sort of the official steps on downloading the kernel source code or the system source code, and running makefiles, and I've built systems, but I've hardly ever understood really what was going on. I can read C code, but it's just so much C code that it's sort of never really tangible. Whereas this system, I felt like there isn't that. There are hundreds of source files, but it's not really thousands of directories. So it's really I don't know, 20 or so directories, and so it gets complicated because of the different processors support and the different system support, which sort of necessarily makes the whole thing a little more complicated. But if you just limit your scope to the system and the processor that you're in, it's more tangible. Anyway, technically it can do multi-user, with multi-serial port. It can do multitasking if you have a timer source. It does run without a timer source, but it still kind of expects to have like a keyboard interrupt. It does implement signals, and it does run without the memory management unit, which initially I was kind of surprised about, but when you think about it, the earlier Unix machines didn't have the MMU support, so it's not too crazy, and that also sort of contributes to the potentially smaller and simpler implementation. Also, I guess, sort of you're limited in what you can do. you do have that, the issue where, a poorly behaving program in user space could, of course, trash the kernel buffers and whatever else and crash the whole machine. But, that sort of goes with the territory on the 8-bit processors, and that's that. Some processors are better supported than others, and the Z80, Z180, 6809, 68K seem to be, actively, there's a couple guys that are tracking Allen's changes and making sure that they, continues to work on their system. Allen seems to be focused mostly on the Z80 side of things. I have seen, but I mean, it almost seems like he has one of everything, but his attention seems to be mostly on the Z80 stuff. Recently, there's a guy named Dave Gibbons that he's contributed the ARM Cortex-M0, which is the Raspberry Pi code, Raspberry Pi Pico, and the ESP8266 stuff. And there's also the 6502, 8088, PDP-11, TIMSP 430 stuff, but they are in, I don't know what state they're in. They are there. There is support for TCP/IP. TCP/IP uses various different sort of these cards that are made to, the cards have Ethernet on it, and I guess it has its own processor on it, and they're meant to sort of interface with embedded controllers and whatever else. So it has a simple interface that mostly supports streams like TCP, and one of the products is called WizNet, I think, WizNet 5200. So that's sort of how TCP is supported. I have personally not tried it and don't know how well it works, but it's there, and I do hear about people doing stuff with it, so I guess it does work. I think what they do is they run a daemon that talks to those, the Ethernet offloaded cards, chips, whatever they are, and sort of brokers that to the other process. So it's not TCP/IP as we know it, but it's not TCP/IP as it's implemented in Linux or Unix, but it's sort of TCP/IP that works for the 8-bit processors. Okay, so yeah, so this is the part where I talk about my personal experience. 2020, 2021, so that's about 8 months ago, maybe a little bit more. A friend of mine, Crawford, we picked up, well, we both had one of these MSP 430 boards, and I guess there was a blog post on a website called Cowlark, Dave Gibbons' website, that he, made that FUZIX run on the MSP 430, which is like an $18 card, embedded controller card. It's the processor number is the FR5969. It has a 64K of FRAM, which is more or less flash, or how should I say this? It's non-volatile RAM. Well, I guess that's what it is. You can turn the power off, and the RAM value is still there. It acts like flash, but there's no complicated flash protocols. You just write to it, and it's there. And you turn the power off, it's still there. Turn it back on, it's still there. And anyway, so got one of those boards. We wired up a SD card to it, and I had FUZIX. Well, actually, this was a little more complicated than that. So we downloaded the tools. We built the kernel. We built everything. Well, actually, the kernel didn't even build from the latest code. And then that's when I discovered that there's a little bit of bit rot. So we went back to the day that Dave Gibbons actually committed the code. That code downloaded and compiled after we figured out that we had to roll back the compiler to the compiler that he was using around that time. And then we had we built the system, we ran it. It ran well, it did stuff, which is to say that, you power it up, it boots through the kernel, it gives you a login prompt, you log in, which is at that point, init has completed running and it hands off to a shell. It's a very minimalist shell, but it does the usual. You type in a command, it finds the executable, it loads the executable, it runs the executable. If you have a pipe, it'll pipe the output to the next program, and so on and so forth. That sort of stuff all ran fine. I spent then the next couple of months trying to get that code base to actually compile and run with the latest code, and didn't quite achieve that. In the end, I ended up, I guess in that time frame, which is, I guess, a couple of years had gone by since that time, and the kernel actually had grown in the amount of memory it needed for itself, and it basically, I couldn't fit it into what I had on the MSP 430 at that point. So back to the drawing boards on that one. I would have to, get further down and figure out how things are going to have to work. So after that, we sort of put that aside, and I have a P112, which I've not been doing anything with for many, many years. It's one of my favorite boards. I have a story to tell about this board. So several years back, I actually accidentally applied 12 volts to it, and it didn't boot. So I kept doing stuff, and eventually, it's bad news, right? 12 volts. Eventually, the flash chip popped. And that's when I realized that, OMG, I had 12 volts instead of 5 volts. And I was very sad, really sad. Sorry, and very angry at myself. So I put that aside. I couldn't even look at it for months. So several months go by, and I worked up the courage to actually desolder all the chips. Well, some of them are socketed, so I took the socketed ones out. I desoldered the main chip. There were two main chips on that board. One was the Z180, and the other one was the Super I/O chip that had the multiple floppy, the printer port, the two serials, or whatever. So I desoldered both of those carefully with quick chip, whatever that alloy is. And I learned to do some surface mount stuff. I found the replacement parts, put it in, and I replaced the other parts. I had a guy help me with this. His name escapes me. He sells Z80 boards on the internet. But anyway, I managed to actually put it back together. So that's the happy ending on that board. I've been looking for something to do with it, so here it is. I got FUZIX to compile and run on it, and that's the board that I brought this weekend. So it's over there. I have a table I can demo, and love to talk to you about FUZIX if you want to come by. So, one of the reasons I'm doing all this vintage stuff is that I like to learn, and all this is a learning experience. And so here's what I learned. I learned I didn't really understand makefiles until I actually had to work with a makefile of that nature. So I learned a whole bunch of things about makefiles and linker files and all that stuff, building systems. Learned more about how the Linux kernel, the FUZIX kernel, which is to say, it builds the same way as any other kernel, I suppose. So I learned more about that. That was kind of fun. I learned not everything is working. Just because it's in the repository doesn't mean it compiles. So that was, not a surprise, but more of a challenge. Maybe I can get it to work if I fix a couple things. And sometimes, it's a motivation for wanting to understand what went wrong. I gained a lot of skills in traveling in time in the repository Git. We rolled back to certain dates. Does that compile, link, run? Sometimes it does, and so you mark that, and then you sort of move forward a little bit. So we did a lot of that kind of exercise, which was kind of educational, very educational. So I learned about the constraints in these sorts of systems would be the memory, and so for example, the Z80 and the banked memory system, it turns out there is wild variation of how banked memory was implemented. By and large, they fall into categories, but if you enumerate the permutations, it's bewildering. So but there is some amount of code already in place and some amount of documentation that describes how you could, if you wanted to, bring this all together and sort of either customize it for your system or see how it works. It's a lot easier on the other 32-bit and other sort of more flat, simpler memory architecture. But for the banked systems, there are combination of factors where, depending on which part of the the memory map is banked, whether you put the kernel above it or below it, and what do you do with the parts that are banked, and those sorts of things. So I was going to actually talk in more detail about that, but the presentation didn't quite work out, and I don't think it's going to be that interesting, or I can't present it in an interesting enough way. So I'll leave it at that. We can discuss more if you come by the exhibit. So I learned a lot about the compiler dependency, or the operating system's dependency on the compiler, in order to bring the whole system together. Initially, by the way, FUZIX was sort of modeled after or built on top of the previous operating system called UZI 180, which was written by another guy. And back in that time frame, it did in fact self-compile, or you were able to build UZI on a CPM machine, or whatever hardware you're running on, you could. Well, it was assumed that it was a Z180 machine, but you could build the whole kernel and the user space from CPM, and then write it to a partition, and then boot that. That was, from what I read, it seems like that was possible, and but that's no longer the case. FUZIX at this point clearly assumes that it's going to be cross-built from either Linux, Mac, Windows, some other more modern environment, I guess. And for the Z80, the official compiler is the SDCC compiler, which is also currently in active development. It's a Z80, pretty modern C standard compiler that produces, from what I understand, pretty good code. It is very slow, and it's very resource intensive. I have, a fairly modern i7 or Ryzen system that still has to grind through it to actually to build. Whereas the TI, I was using a GCC compiler, and that, relatively speaking, that was much, much faster in producing the final product. So, and SDCC also has its limitations. This is sort of not many other people are sort of compiling an operating system for it, so they don't actually support some of the, the memory banking models, or doesn't produce the C code to work smoothly with the banking model. So there's some patches that people had to make to do that. And then, some thought experiments. At the end of the day, you only have either 32K, maybe sometimes more of space for the user program, and that's really kind of tight. And if I was to want to compile a C program that needed more than 64K RAM, what do I do? So maybe using a compiler that can produce overlays, or having some kind of overlay mechanism might be interesting, possible to make things better. So that's about where it wraps up. I have been thinking about what I would do potentially to contribute to the project some more. One of the issues that came up was that the developer experience isn't that great. You sort of have to really know how to put together the development environment yourself. They do mention, and most people seem like they're running Ubuntu 20, and so there is a guy that's producing the packages, SDCC, with the patches in an Ubuntu repository, so that's great. And if you're familiar with that, that's all fine. If you're not, then it's a little challenging. So I thought maybe I could build potentially Vagrant boxes, or some kind of mechanism for distributing the whole entire development environment so that people can just download it and run it, so that they're in a, they download the run, they check out the source code, and they would be in a position to, compile and test out the code. Something like that, I think I can do. Potentially, I think the project's always in need of documentation, more documentation, or even sort of curating the documentation, because it is lots of code and scattered all over the repository. And I also have a couple other Z180 boards that, I'd like to spend some time potentially trying to port. So that's that. Yes. So in doing all this, I did spend some time trying to figure out where the people are. So if I needed to, where are people discussing things? And I found that there isn't a mailing list. There is a mailing list. It's right here listed, and I have it linked from the resources page. But not a whole lot of discussion happens there. Some. Alan himself has a Hackaday page. If you go to Hackaday and search for FUZIX, you'll land on his page. And that's where, and then the most of the real discussions seem to be happening in the GitHub issues themselves. So I actually have never seen this in a project, but that seems to be the case. So I had to turn on all my notifications for the repository. I got, and then I started seeing the chatter a little bit. So, and finally, I wanted to give a shout out to David Givens. He has a YouTube channel that has, this must take a lot of courage and probably also a lot of time too, but he basically sits down and he starts writing code, and he's talking his way through it, and you get to see him do all of this. So these videos are like 4 hours, 6 hours long, and they're like a dozen of them. Of course, that goes with, there's a lot of noise to sort through, but I found him actually educational. I think he probably does embedded development for a living. So he knows his compilers, he knows C, and he's been doing it for a long time, and he just, so he goes through stuff, and I usually go through it and watch it at higher speed, but I do stop and rewind and slow it down, and so anyway, so his YouTube channel is over here, and that was I hesitate to say I recommend it, but if that's the sort of thing that you can deal with, then definitely check it out. There's I was looking around for something to talk about as well. There's one guy that's written a MIDI player, I think, and he targets FUZIX. So don't know why. I don't know. I don't know what else he's doing, but I did find he's a Japanese guy that had a Twitter or something post. So thought that was interesting. And that's it. That is my presentation. I'm here to answer questions if I can. Go ahead.
Is FUZIX really, the purpose is to learn about an operating system, or would it have any advantages over something like FUZIX or NPM?
Right. So one of the things that would be different is the hierarchical file system. So you get that. Do you get that in NPM? I know you get multi-user stuff. Multitasking, but do you get the longer file names with the paths anyway? So that was one of the things that was mentioned. Yeah. That's a good question.
FUZIX was modeled after Unix, so it might be a closer comparison.
Yeah, I'm not terribly familiar with Chromix, so I can't answer to that. As for NPM and CPM, I think one of the advantages would be you're programming in C and you get the whole sort of the Unix API, but also you're cross-developing, so it's not the same. For me, it was all about learning how things work. So yeah, go ahead. Yes. So the question was to describe again the compromises that were made to fit everything onto the smaller system. Sure. So let me go back to the, I don't know if I mentioned it, but the definition of small, I had a definition of small somewhere here. So the definition of small is basically 8-bit processors with 128K RAM for Z80. I think there was some mention elsewhere that, or somewhere that I read that it might fit on a 64K if you're on the 6809 processor. But the compromises are, so the features are fairly limited. You have files, you have processes, you have libraries. You don't have any dynamic loading. So no what is it? No shared object. So the object format is very simple. It just loads. There is, as it stands today, there is no anything that takes advantage of the position-independent code. So and Z80 doesn't even have that. So so you're limited there in that the compiler actually needs to help you, sort of write the code. And there is no fix-up or load time, anything about the binaries. So so that that part's sort of really simplified. There is, what else is missing? There's no floating point, none whatsoever. What else? Other than that, I mean, there are pipes, there's processes, there's signals, and there is swapping. Yeah, so I forgot to add to that definition of small that you need. It really sort of assumes that you have some kind of disk and block device disk. Today, it's most common to have SD cards. So there's a machine-independent SD card driver written in C. And I have a compact flash, but that's another alternative that seems to be Yeah, so it'll probably fit on two, so what am I trying to say? A kernel plus, maybe not all of the utilities would fit on but a small set of utilities subset of the utilities will probably fit on a floppy comfortably.
3.5-inch high density.
Yeah, 3.5-inch high density, yes. I didn't mean the lower density ones, but yes. Yeah?
Can you talk a little bit about what David actually did in his video presentations? Because I think I found it fascinating as you did.
Yeah.
He live coded.
Yes, he live codes stuff. In fact, maybe I can just bring up his YouTube channel. Was it? I think his handle is like hjalfy. Yeah. Okay. So and then here is how do I do this? Playlists. How do you find his playlists?
He live codes assemblers and things like that.
Yeah, so he has a playlist of here the 8266 stuff. Unfortunately he doesn't have it for the Raspberry Pi. Oops, didn't mean to play it. I just want to get to the list of them. And this is number 13. So he's got like several of these, and this one's an hour and 40 long. So he starts with setting up the tools. And he compiles a small binary to make sure that he can sort of send that down to the I guess he's working on a card, and then he really builds his way up to getting the whole thing to run. So and he goes through basically all he his usual tricks and tips about how to verify each of the steps on how things are working. In the particular case of the 8266, it's complicated because some of the code / what he wants to use as a library is already on the chip. And so he needs to then work with that and be able to call it. But when he calls that code, he needs to set up the registers and the memory sort of just right so that the code is sort of expecting or can find what it's expecting to find. So he does that. He goes back and forth with the compiler. He disassembles the stuff that he writes to verify that it's working. And he just sort of builds his way one step at a time up through all of that. And it really takes like, I think there must be like 40, 50 hours worth of footage. And some of them, there's a whole session where he just sort of, things just don't go well for him. But he's recorded through it, and then he comes back the next day saying, okay, I did a little more research. That didn't work out. These are probably the things that I did wrong, and so we'll start from that. But then he goes through and so he builds the kernel, he tests the kernel, he builds the user land, he tests the user land, he makes sure that the kernel can start the user land stuff, and so on and so forth. So it's pretty extensive. In fact, I haven't watched through all of them myself, but parts that I did watch were and he does edit some stuff, and some of the parts where he's just waiting to compile, he just cuts out, and he just like 2 seconds later it's done, and he's testing it. So anyway, I believe he does the whole port of FUZIX in these 13 plus videos. So I have a table. I will be here all day tomorrow. I'll try to spend as much time at the table as possible, and I'm leaving kind of early on Sunday, so I won't be around Sunday afternoon. I do have two Z80 boards for sale in the consignment area. One's a SB180 by Steve Ciarcia, featured in Byte magazine whenever it was. It was a classic. And then the other one's a BCC 180, which is from Micromint. It's also a classic. But anyway, that's it. Just say hi if you want to talk more about this, or if you're a fan of the Motorola 88,000, because I'm looking for 88,000 friends. All right. Thank you very much.